Good evening, all. A warm welcome to the fifth day of the ATAL Faculty Development Program on Progressive Safety Engineering Strategies in Manufacturing and Industrial Applications. Let's take a look at the today's resource person's profile. Welcome, Mr. Stephy James, a distinguished safety and fire engineering expert with 18 years of academic excellence and 10 years of industrial audit and consultancy. Quietly, an associate professor at Kochi Institute of Science and Technology, Kochi, and PhD candidate at QSAT, Kochi, Mr. Stephy specializes in risk assessment, fire protection, HSE management, and human factors engineering. NEBOSH and IOSH certified, Steffi is a dedicated professional committed to bridging research and practice for safer workplaces globally. Now, I would like to request Mr. Steffi James to kindly start the session on hazard identification and risk assessment. Welcome, sir.
Thank you, Deepa, for a
Thank you,
good
sir.
introduction. Shall I start?
Okay, sir.
Yeah. Screens are visible, right?
Yes, yes, it is visible.
Changing, no? Changing. The slide is changing now.
Yeah.
Yeah. Okay. So, good evening, everybody. So, today's topic is about the hazard identification and risk assessment. And I'm very happy that around 30 plus people are participating. I hope everybody is from Polytechnic professors or anybody industrial people are there, or all Polytechnic professors, participants. Deba, all people are Polytechnic people, or can you specify?
From engineering colleges and PG scholars are also there.
PG, MTech students are also there.
Yeah. Then from engineering
Oh,
colleges is also.
oh, faculties from engineering colleges are also. Oh,
Yeah.
that's great. That's great. So, first of all, this one and a half session, we are discussing about what is hazard monitoring, risk issues, and hazard assessment procedure, methodology, safety audit. What is the significance of safety audit? How do we conduct safety audit? What is the tool used for safety audit? That is checklist. And what are the techniques used for hazard identification and risk assessment, like what if analysis, safety review, preliminary hazard analysis, hazard operability study, faulty analysis, inventory analysis, minimal cut set method, fire explosion toxicity index, and FMEA, and a small glimpse of a consequence modeling. Hello. Before going in detail, so what is the general idea? What is hazard? As you all know, according to International Labour Organization statistics, around 3 lakhs 40,000 people are affected by accidents every year, every day in this world. And what are the various types of industries causing accidents? And what are the various other type of accidents which cause fatality to people? Surprisingly, it is not industrial accidents are not killing the people the most. It is actually road accidents. Road accidents, if you take the statistics in India, around 1.5 lakh people are dying in India every year, average. And the second place is United States, around 36,000 to 40,000 people are dying every year in this world in road accidents. If we come to industrial accidents, according to ILO, the road accidents are higher and industrial accidents are lesser. So anyhow, what is the reason for these accidents, or what is the cause for accident, or how we can reduce the accident? So we have to understand some terminologies like hazard, risk, unsafe act, unsafe condition, dangerous occurrence, and all that things. So what do you mean by hazard? Hazard is generally considered as something has a potential to cause a harm. That is called a hazard. That may be a unsafe acts, or unsafe condition, or a situation, or a combination of all these things has a potential to cause a harm is called hazard. Now, this is nothing but hazard. Something has the property or potential to cause a damage to people, property, or environment. So simply we can say the examples of hazard, maybe the presence of high pressure or temperature in the system, lack of lights or glare, act of smoking, explosive properties of the material, or maybe the human error, that is overconfidence, inappropriate behavior of staff, storage of large quantities of toxic substance, rotating machineries without guarding, industrial operations near to high population density urban areas. So we can have hazard classifications like physical hazard. What do you mean by physical hazard? Anybody? Let it be more interactive. So I can ask some questions and we can interact. I can get your knowledge also. Physical hazard is nothing but pressure, light, noise, vibration, extreme temperature, and all. Can anybody say an example of sources which produce high noise? Anybody in industry? What are the equipments which produces high noises in industry? Or what are the places where high noise will be there in industry? Anybody? Anybody can answer? Otherwise, it will be only a one-way communication. That is, we try to break the limitations of online sessions by interacting each everybody. No problem. If anything goes wrong, no problem. Can anybody? Srijit PS, can you respond?
Sir.
Yes, sir. Good evening, sir.
Good evening, sir.
Yeah.
And during the working of fabrication units.
Yeah, of course. Like yes, correct. Cutting operations, knurling or grinding, extreme noise will be there. During fabrication, all these activities is done. Yes, correct only, sir. Anybody else? Yeah. Yes. Somebody was just unmuted.
So
Yes, sir.
It can be a movement of forklift, then conveys.
Yes. Yes, sir. Correct only, sir.
Okay, thank you.
Conveyors, high pressure steams, blowers and high compressors, highly, heavy rotating machines. All these things produces high noise. And in industry, according to Indian Factories Act 1948, the permissible noise level for an 8-hour shift is 85 decibel. And there are a lot of physical hazards like high pressure, lights, lack of light. Somebody is doing a cutting operation. There is no sufficient light. What will happen? Sometimes there will be a cut in the hand, and maybe and another thing is vibration. If you are exposed to high vibration, like jackhammer or anything like that you are using, that maybe causes some ergonomical issues. Extreme temperatures. If you are working in a steel industry, if you are working more than 40 degrees Celsius for a long time, you might have caused dehydration. Dehydration is nothing but our water content in our body is getting exhausted, and we sometimes, goes to unconscious stage, or we will be collapsed. So these things can happen. This is physical hazard. And chemical hazard. This is very important. Anybody is from chemical engineering background, you can say the major hazard of an industry comes under chemical. In industrial hazard, the major hazard is fire, explosion, and toxic gas release. If you take an industrial perspective, this is actually a manufacturing and industrial application ATAL FDP. So mainly if you consider industry like a refinery or any manufacturing industry, then the major hazard is fire, explosion, and toxic gas release. These comes under chemical hazard. So can anybody say what is the major area where a fire hazard probability is there? Anybody? Or somebody? Yeah, Nitin John, can you tell me?
Sorry, can you please repeat the question?
See, where are the probability of fire in an industry? Fire hazard. In
Uh,
which industry has fire hazard?
some petrochemical industry
Yeah,
can have.
absolutely, you are right. Refineries. Why refinery has more hazard? You can explain? Can I explain?
Because
Refinery. Ah,
petroleum products are most likely can have fire.
exactly, sir.
They are
So what
flammable.
refinery does? What refinery does?
Uh, that I don't know, sir.
Actually, refinery is
Exactly.
simple, sir. Simple, sir. Refinery is actually processing crude oil to produce petrol, diesel, naphtha, gasoline, butane, propane, LPG, aviation turbine fuel, kerosene, lubrication oils, tar, bitumen, tar, and petcoke.
Okay.
So all these process, if you take, Usha madam, can you respond? What are the major causes, or you might have studied about fire triangle? Now, three things required to create a fire. What are the three things? Usha madam can tell. Usha, is there anybody called Usha? Gopakumar? Usha Anand, I was talking to Usha Anand. Usha Anand is not available. Gopakumar is there? Gopakumar? Yeah, can it respond, Gopakumar sir? I think he has a mic problem. I know Paul. Or Irishma, Ashwati,
Hello, sir.
anybody can respond. Yeah,
Govind.
yes, sir. Yes, sir.
Hello.
Yes. I am talking about fire triangle. Fire triangle.
Uh,
Three sides are
yes, sir.
there, no? Fire triangle.
Yes.
Yeah, do you have any idea about that?
Fire triangle, fuel oxidizer, and heater.
Absolutely. You are right, sir. Correct answer. I think everybody should give a big clap to sir. Fuel, oxygen, and heat. These three things are required to create a fire. So, like that, fire can be extinguished by suppressing any of the sides. Heating can be controlled by providing cooling. That is what our Kerala Fire Force is doing. Pouring water into the source, thereby heat is suppressed by cooling, by cutting the oxygen, by using maybe DCP, dry chemical powder, or foam, or carbon dioxide. All these mediums are used. So anyhow, chemical hazard is very, very dangerous, and it is one of the most dangerous hazard among all these things. It comes under chemical hazard. We have fire, explosion, toxic gas release. I will ask a question that among these three, fire, explosion, and toxic gas release, which is more severe? Anybody? Fire, toxic gas release, and explosion. So which is more severe? Which has high severity of consequence or something like that?
Sir, toxic
Yeah.
chemicals.
Exactly correct, madam. Can you tell me your name? Good name, madam.
Sir, Grishma.
Grishma, madam, you are absolutely right. Give a
Thanks.
big clap to Grishma, madam. Toxic gas release is the worst among all these things. Because if suppose a fire accident happens, sometimes somebody will get a first degree burn, second degree burn, or something like that. Explosion happened also, someone, one or two people may get fatality, or maybe even worse. But toxic gas release, what it happens, if a toxic gas is released and either wind is high, or wind um, in a high speed wind is there, it will take this toxic gas release outside the industrial premises also. We don't have any control over this. Can we control the wind? Not possible. So based on wind direction, this toxic gas goes to kilometers and kilometers, and those who are, all people are inhaling this toxic gas, they all will die. That is what happened in Bhopal tragedy. Everybody knows about Bhopal tragedy. Bhopal tragedy happened in 1984, December 3 midnight. 40 years back it happened. It is one of the worst disaster happened in the world. Anybody, any chemical people might be knowing what was the toxic gas in Bhopal tragedy. Anybody? This is actually an interview question. Many chemical engineers, public this one competitive examinations, this question appears. What was the gas? If nobody knows, shall I answer? It was me. Anybody? Yes. Please. Tell me, sir. Somebody was
Methyl
unmuted.
isocyanate.
Yes, correct, sir. Methyl isocyanate. Your good name, sir?
Dilip Kumar Naik.
Dilip Kumar. You are from which place?
Bhubaneswar, Odisha.
Yeah. So you know better. So Uttar Pradesh. Actually, the Bhopal is the capital of Madhya Pradesh.
Yes, sir.
Yes, sir. So thank you. Thank you. So your answer is correct. It is methyl isocyanate. That was a toxic
Thank you,
gas
sir.
released during that time. Thank you, sir.
Thank you, sir.
Yeah, and the next classification is mechanical hazard. Everybody knows about the various mechanical hazards like trapping, impact, contact, entanglement, falling, crushing. I'll show some video. Shall I show some video? Is it okay? Deepa madam, shall I show some videos? Is it okay?
Yes, sir. Yes, sir.
Yeah, yeah. Okay. Then I will show some videos. A minute. Yeah, we were talking about this now. That is mechanical hazard. You can see here the various mechanical hazards here. The see this fellow is actually trapped his hand out here. See, his hand is trapped out here. This is actually a mechanical hazard. And also you can see here, this is actually a rotating machine. A lady here, you can see a rotating machine without a guarding. See, this is what happens. Immediately somebody saw that and he offed this thing. And you see this is actually very dangerous. That white color shirt boy is just closely watch this boy. White color shirt boy, he just closely watch. He's just putting some paper or something like that into the roller. Very unsafely he's doing that. And he goes inside. See, he just goes inside the roller. He got crushed into the roller. So these all are mechanical hazards. And you can see somebody is falling from height. See this video. See, one person is climbing without. See, what is the PP used for working at height? It is harness. You have to use harness, and harness has to see. He fell down. He fell down and spot. He died. And you see this video. He is wearing the harness here. This is actually the harness, and he's hooked the harness here. If suppose he's slipping from this height, because he has hooked the harness here, what will happen? You can see that. Suppose he is slipping from this platform. Yeah, he is slipping. Yes, he slipped. Now, because of this hook, he has hooked this harness in this lifeline in this area, and that is why he survived. These all are mechanical hazards. Okay, and I'll show some more videos in between. So this is about the mechanical hazard, that is scrapping, impacts, contact, entanglement, falling, crushing, all these things comes under mechanical hazard. Electrical hazard. Somebody want to see the electrical hazard? Electrical shock, electrocution. Anybody can say what is the voltage in electric train? Suppose somebody hits the electric train, what will happen? Electric train, what is the voltage in electric train?
25 kV.
25 kV. Suppose you are touching in 25 kV, what will happen? See, electrical. If suppose you are touching on a 25 kV, this will happen. See, electric train. Here you can see the electric train. You touching. If suppose you are touching the 25 kV line, that is actually 25 kV. He touches and he Margaya died. Ford died. This will happen. Train accident I am talking about. And see this. This is another electrical accident. See. He touches the overhead line, immediately they got electric shock. This is what happens. And you can see there is a lot of videos here. Electrical fire. Here this person is actually repairing in a control panel. And he is charging the line. And there is a short circuit happen. See, charging. Short circuits. Okay. These all are electrical disasters, electrical accidents. So electrical shock, electrical fire, all these things are. And biological hazard, everybody knows about COVID, virus, bacteria, dengue fever, effluent water problems, food handling and personal hygiene. And ergonomic hazard, this is actually because of the improperly designed tools, poor planned work area layout. So repeated motion if you are doing, sometimes you will be having neck pain, leg pain, body pain, back pain, hand arm vibration, musculo. These all consider musculoskeletal disorder, MSD. Mechanical engineers might be knowing about it. MSD, hand arm vibration, everything comes under MSD. Or maybe we can say CTD, that is cumulative trauma disorder. All these are ergonomic disorders. Can you identify the hazards here? What are the hazards here? This is actually a cartoon picture. Can anybody identify what are the hazards? Anybody? Usha madam is there. I called Usha 2-3 times. Usha is there. Yes, tell me. Yes, anybody else? What are the various hazards? You can participate in the question answer session. This is actually a kitchen. So what are the various hazards you can see?
So electric plug is openly kept.
Yeah, electric plug is openly kept. That is a hazard. Electric shock. You can see that extension plug socket combination. You can see it is in the ground. So there is a chance of electric shock. Then fire hazard is there. There is actually slippery floor is there. Exactly correct. Very good. Slippery floor is there. Then, and you can see somebody there. Cigarette is there. See, cigarette smoke. So cigarette can get a fire. And here actually it is actually burned now, and it is about to get fire. Slippery floor. Here also. Knife is here. So sharp edges. All that things again. And here also this is actually an office room. Here this man is actually can fall from height. There is some wires here. So all these things office. And these are this bureau, electrical problems. He is lifting the load in not an ergonomic way. Air conditioner is, there is a chance of short circuit or there is a fire, smoke, something like that from the air conditioner. These are the various hazards. So major industrial hazards, as I mentioned, fire, explosion, and toxic acid leak. These are the major industrial hazards. So fire is the most frequent of hazards, however, the consequences are generally less. Fire hazards. Fire can produce toxic fume also. And if sometimes recently there was an incident happened in Kuwait, there is a building fire, and if you see the casualty of the people, there is no burn at all. Then how the people die? Because of the smoke, on the before it comes to CO2, it will produce CO, carbon monoxide. They inhale carbon monoxide. Carbon monoxide is also very dangerous. So fire can produce toxic fumes like acrolein, carbon monoxide, and cyanates during the physical structure, during a building damage, during a building fire. This carbon monoxide, acrolein, and other cyanates it will produce, and people inhale that, and thereby they die, not always because of the heat radiation. Do you understand? So that is one thing. So cause skin burn due to thermal radiation, that is another thing. Severity of burn depends upon intensity of heat and exposure time. Human skin can withstand heat up to 10 kilowatt per meter square for 5 seconds. So more than that, it will be damages the epidermis. The skin have various layers, first degree burn, second degree burn, all that things will be there. So if it is more exposure, 50 kilowatt per meter square and all, it can damage to third degree burn, second degree burn, like that. So this is another area, jet fire. What is jet fire? When pressurized vessel or pressurized pipeline, there is a small crack or any type of hole or any leakage happen, and if it is ignited immediately, that will result in jet fire. This is called jet fire. So you can see the jet fire. And pool fire. Actually, from a storage tank, it comes out. Maybe diesel or petrol, it comes out, and it will be covered in the dipole. If suppose storage tank, there will be dipole will be there. Dipole is nothing but what you can say, a bundle. Dipole is provided. Anybody knows why the dipole is provided in the storage tank? Dipole is provided that to protect the industry, that if suppose there is a leakage from the storage tank, it should not be exaggerated, or it should not be spread out to various other layouts or other facilities. It should be contained in the dipole. Dipole is just like a barricade, by the concrete structure, a barricade. It should be contained inside that, so it will not be spread out, and there will be no problems with other facilities. So that is called pool fire. This is flash fire. Actually, it's also known as vapor cloud fire. Actually, if suppose LPG, I mean butane or propane, is leaked and it has not immediately got fire, it will form a vapor cloud. It will go on top and it may make a vapor cloud, and then it will got ignite. That is called flash fire or vapor cloud explosion. And this is blevy. Hey, can anybody know what is blevy? Can anybody explain what is blevy? Boiling liquid expanding vapor explosion. You might have seen LPG bottle. Now, LPG bottle, what is inside the LPG bottle? What chemical is there inside the LPG bottle? Anybody? Which chemical is there inside the LPG bottle? Anjana? Darshana, Mary. Anybody? So what is the chemical inside the LPG bottle is? It is the combination of propane and butane. And originally, this LPG does not have any odor at all. Doesn't have any pungent smell. Then how does it smell? If suppose from your household domestic application LPG is leaking, you get a smell, no foul smell. Actually, there is a chemical added into that. That is called ethyl mercaptan. The chemical is added to detect or to identify the LPG has been leaked. So by this chemical adding, easily people can understand that If it leaks, a foul smell, it detects, oh, LPG. And this blevies happens, as you all know, LPG is actually liquefied petroleum gas. Under pressure it is. It is pressurized and liquefied. If suppose, if it leaks, and do you believe that if suppose from the nozzle of the regulator, if it got fire, the fire will go inside the cylinder and it will explode? It is not happening like that. Because of the fire, the outside elements, maybe paper, wood or anything like that, it get fire. So outside temperature of the LPG cylinder will increase and the liquid inside the LPG starts boil over or something like that. It will become gaseous, or it will convert to liquid to gas, and the pressure increases in the inside the tank, and the tank is designed for a certain pressure. If it exceeds that pressure, what will happen? It breaks, or containment break and burst, or that is called boiling liquid vapor explosion. Boiling liquid expanding vapor explosion. That is blowing. And this is what explosion. You have seen Beirut explosion. In Lebanon, ammonium nitrate exploded. Various explosions happen in various places. So dispersion, what is dispersion? Dispersion is nothing but a sudden release of toxic vapors. They have a potential to cause death and severe injuries. Methyl isocyanate, carbon monoxide, hydrogen sulfide, sulfur dioxide, any types of cyanides, chlorine, ammonia, all these things can leak and it can inhale. People can inhale it, and that. So the dispersion of toxic, this is what I said, Bhopal tragedy, Union Carbide Limited. Around 60 ton of methyl isocyanate was leaked on that day. And so many people killed in that disaster. This is considered to be one of the world's largest disaster after Chernobyl. So this accident happened in 1984, and around 42 tons of MIC, 30 metric tons of methyl isocyanate escaped from the tank to the atmosphere in 45 to 60 minutes. The MIC methyl isocyanate are large tanks and refilling beyond the recommended levels, and poor maintenance, failure of several safety systems. Actually, they have cost cutting was there. The cost cutting done on safety. There was no scrubber system, flare system, bypass tank system, refrigeration system. There is no qualified and educated, trained people were not there. So they have cut the cost for everything. And what happened finally? It was an American company. They made poor Indian life has to be sacrificed for their carelessness and therefore lack of safety. And our people are suffered. So many people killed in that disaster. So risk is nothing more. What do you mean by risk? Risk is actually a combination of probability of occurrence and its severity. This is what? Probability, P, and severity of consequence. Or probability into severity. Can anybody say that probability means what? Probability is nothing but how frequently an accident is happening. That is called probability. And what is severity? Severity is nothing but what is the consequence of that. So the multiplication of these two things will get probability and severity, the risk. This is actually risk matrix, the basic of hazard identification and risk assessment. We just want to calculate how probable the accident is, once in a week, once in a month, once in a year, once in 10 years, once in 100 years. How frequently an accident happens? Every day it happens. So it is more frequency. 100 years, once in 100 years means it is very, very less frequent. So that is nothing but the frequency. And what is the consequence? A small cut, small injury. Then the first degree burn, second degree burn, one person died, 2% died, 10% died, 100 people died. So see, this is how the consequence increases. So you can see three colors here. Probably it will be in many industries they use three colors like green, yellow, and red. Green, yellow, red. You can imagine like that. If it is red means it is intolerable or unacceptable risk. And yellow means it is acceptable, and green means it is yellow means it is tolerable and green means it is acceptable. So intolerable, tolerable, acceptable. These the three things. Or we can say here it is written like unacceptable, alarm, acceptable. Alarm region is nothing but as low as reasonably practicable. That is nothing but tolerable. So high risk means it is intolerable, then tolerable, then acceptable. These are the three risky and rank. This is an example. We all know that skydiving is a risky sport. The risk here is the potential for serious injury or loss. So what is the why it makes risky? The consequence is very high. If suppose you fell down from that, death is sure. So that is why the consequence is very high. Okay. Now I'm coming to this. Okay. Now this is the flowchart for risk analysis. Risk analysis. So here the main thing what you do is we have to define the goal, then location, layout and all that things, hazard identification, quantification of hazard, select the most credible scenario, select the worst case scenario, estimate the consequence, estimate the effect of damage, then whether it is acceptable or not. If it is not acceptable, then estimate the frequency of occurrence, estimate the risk and prioritize and reduce the risk. We have to prioritize the risk. See, there are a lot of incidents happening in industry. Many of the hazard identification tool has prioritization techniques also. If suppose you take Chandrayaan 3 rockets and space mission, there are 10,000 or more than 10,000 of components will be there. So which components failure collapses the entire mission? That components has to be given the highest priority. And that component has to be, redundancy should be there. If suppose that component is failed, another component has to be taken. So 3 or 4 times redundancy is required and high reliability is also required. So that is nothing but. So goal of for carrying out risk analysis is required as part of statutory requirements, emergency planning, etc. And the quantification of hazards indices, method for hazard identification and the quantification. And just skipping on. This is the risk assessment basic idea. That is actually system definition, hazard identification, analysis of accident scenario, estimation of accident frequency, consequence analysis and modeling, risk estimation. Why do you want to estimate the risk? Once you estimate the risk, then only you know whether the risk is high, medium or low. What do you do if the risk is high? Imagine your college classroom. I'll ask a question. A faculty, a college classroom, imagine a college classroom. Darshana Mari, I called you 2 times. Are you there? Darshana Mari. Darshana Mari is not there, means we just go to Dilip Naik. Dilip Naik.
Yes, sir.
Yeah, are you faculty?
Yes, sir.
Yeah. Sir, in your college, in your classroom, somebody asked you to assess the risk, fire risk. If suppose the fire risk is high,
Yes, sir.
imagine in your classroom the fire risk is high. How we can reduce the fire risk to low or medium?
Sir, we have to keep fire extinguishers.
Yes, absolutely, you
fire-
are right.
fire
Fire
alarm
extinguisher we
system?
can provide, fire alarm we can provide, sprinkler system we can provide, fire
Yes.
hydrant we can provide, fire exits, fire doors has to be provided. So thereby we suppose, do you have all this system in your classroom?
Yes, sir.
Then your risk is very less, fire risk is very less.
Yes, sir.
Everything is provided in your college means your college is taking care of you very well.
Yes, sir.
So,
We are approved, sir.
you are approved. Okay. Which college it is?
Synergy Polytechnic.
Synergy Polytechnic from which state?
Bhubaneswar, Odisha.
Orissa. Okay, Bhubaneswar. Oh, very good. Synergy Polytechnic is maintaining a very good standard. So the
Yes,
fire risk is very less. But in many of the institutions or hospitals, you can see there is no sufficient mechanism for reducing the fire risk or hazard control. So there's various techniques used for hazard identification are what if analysis, checklist, ASOP, task analysis, Dow index. And these are the various qualities. Generally, we classify the this thing, what is it? Hazard identification, risk assessment techniques into two categories. One is qualitative technique, one is quantitative technique. Another one is semi-quantitative technique, that is layer of protection analysis. Layer of protection analysis is actually semi-quantitative technique. So qualitative technique means, again, as I can simply explain you, I ask you somebody that how is the rain? You can say a qualitative and quantitative answer. Prilly VF. Prilly VF not available. 71 people are here, but most of the people are not available. Gopika NE. Okay. So the effectiveness of the FDP may not be that much good, I think so. Because they just open it and they went somewhere else. Jishnu K. Jito George. Okay. Anyhow, no need to ask questions. So if suppose somebody asks you a question like this, how is the rain? The qualitative answer is, the rain is very good. Heavy rain, low rain, medium rain, or there is no sufficient rain, very less rain, poor rain. These are all qualitative answer. Can anybody say quantitative answer? How is the rain? Somebody asked you. How is the rain? Quantitative answer?
200 centimeter.
Yes. Correct answer. 100 centimeter, 200 centimeter, 50 centimeter. It's a quantitative answer. Likewise, how is the rain? We ask. How is the rain? High risk, low risk, medium risk, very high risk. The risk is this much. 0 to 10 scale, we say it is 5, 4, 3, 2, or in 2 into 10 power minus 1, something like that. So quantitative answer will be there. So quantitative techniques are faulty, FTA. FTA is nothing but faulty analysis. ETA is inventory analysis, PTA is BOTA analysis, Dow index, FME, CA, failure mode effect and criticality analysis. Earlier I said about Chandrayaan mission. So we can find out, or we can prioritize the various results based on this by finding the RPN. RPN is nothing but risk priority number, and by using the risk priority number, we can calculate the. Okay, so that is about RPN, risk priority number. And PHA, these are the qualitative techniques. PHA means preliminary hazard analysis checklist. What is JSA? HAZOP means hazard and operability study, and FMEA, failure mode effect and criticality. Failure mode effect analysis. So scenario, so sequence of events which causes hazard to result in accident. So risk analysis, quantitative estimate of risk using engineering evaluation. It involves estimation of hazard and probability of occurrence. And you see here, this is the formula which is used for finding the individual risk. Number of fatality divided by number of people at risk. So you can find out the individual risk, and it can be measured by using a technique called risk counter. And societal risk can be mapped by using a graph called FN curve. And this is already I mentioned ALARP. ALARP is nothing but as low as reasonably practicable, which is actually describe the level to which we expect to see the workplace risk control. As I mentioned in LR triangle, you can see like 3 regions. The top region is high risk region, that is intolerable, then tolerable, acceptable. These are the various 3 regions. Like acceptable, we can say unacceptable or intolerable, then tolerable, then acceptable. These are the 3 regions. You can calculate the risk, and if the risk comes under intolerable or unacceptable region, what do you have to do? We have to add more safety systems to this, and Dilip Naik. Just somebody can mute Dilip Naik. Anybody is there to mute Dilip Naik? Can mute Dilip, actually unmuted. Okay. Okay. Then next thing is, this is the first method, checklist. We used to do checklist method for doing safety inspection. Checklist is actually the IS 14489 is there. This is the code of practice for safety audit. So checklist around 400, 500 questionnaire will be there. Whether any safety systems, checkpoints, safety policy is there, sufficient fire extinguisher is there, sufficient sprinkler system is there. There is any electrical record is there, license is there, that is there, this is there. Lot of questionnaire will be there. This is the method by conducting safety audit, that is checklist. The necessary addition column can be added based on the requirement. So traditional checklist generate a list of response to the standard checklist questions. And more general checklists may be produced. Various types of checklists are electrical safety audit, we have to prepare another checklist. Mechanical, chemical, or environmental, ETP, all that different types of checklists. This is actually checklist analysis. Identify all probable source of spillage which can be caused. Overflow, backing up, blow up or airlock vapor system, equipment protection action, excess pressure, wrong routing, or loss vacuum, overloading of an open flow conveyor, poor isolation drains or doors, open flanges. So we can have yes or no, and whether it is there or not. Next technique is what if analysis. What if analysis is very simple technique. We just ask questions and we get answer. If suppose if there is a fire accident, what if? If suppose valve A is open instead of valve B, what if? If suppose any substitution of a wrong material into the reactor, what if? So keep on asking what if, and find out the answer. So this is like proposed what if question and identify the scenario and consequences and recommendations. This is actually the table we have to. I just explain. This is actually an example of what if analysis. Ethylene feed is contaminated. What if? So what is the consequence? What is the recommendation? What is the responsible? This is a worksheet for what if analysis for a particular plant. So Cl2 feed is contaminated, chlorine feed is contaminated. What if? So what is the what if the chlorine feed is contaminated? What is the cause? What is the consequence? What is the recommendation for that? And also here we have a example of DAP. DAP means diammonium phosphate. Diammonium phosphate is actually, this is a diagram for diammonium. This is a simple process. You can see here, this is actually, this is ammonia, NH3. NH3 and H3PO4. Phosphoric acid is H3PO4. NH3 and H3PO4 is reacted. NH3 and H3PO4 is reacted to produce or to manufacture DAP, diammonium phosphate. Here you can apply what if analysis. The what if questions are, what if wrong product is delivered instead of H3PO4? If suppose H3PO4, instead of H3PO4, some other material is feed to the reactor, what if? What if H3PO4 is wrong concentration? The stoichiometric concentration has to be maintained, otherwise instead of DAP, some other product will come or out of specification product will come. So what if H3PO4 is wrong concentration? What if H3PO4 is contaminated? What if valve B is closed? Like that, keep on us. What if valve C is closed? What if vessel agitation stops? Like this, keep on ask questions and find answers. This is a simple way of finding out what if analysis. Safety review is not much important. I am skipping this. The next one is preliminary hazard analysis. This is actually a little more important. Preliminary hazard analysis is actually invented by a US military for to identify the various hazards in the early design process or during the PNID. PNID means during the pipeline instrument or process instrumentation diagram or pipeline instrumentation diagram. During the design phase itself, we can find out various problems like facility characteristics, like plant equipment, facility layout, operating environments, operational activities, and all. Now I come to the this thing. This is the actually PHA. The hazard can be classified into category 1, 2, 3, 4. Hazard category 1 means negligible, 2 means marginal, 3 means critical, 4 means catastrophic. This is actually documenting the risk. This is actually the worksheet. You have to understand the worksheet of every hazard identification. This is the worksheet for PHA. So we have to list out the hazard. What is the cost of that hazard? What are the major effects of that hazard? What are the hazard category? Hazard category already I just mentioned. Category 1, 2, 3, 4. Like that we have to. And the corrective action. This is a simple example of PHA. Here, what is actually happening? The analysts recognize that H2S has toxic and flammable properties, and analysts identify the potential release of H2S as a hazardous situation. The analyst lists the following possible causes for such release. So here you can see this is the Consider the process that stores alternative less toxic material that can generate H2S as needed. And hydrogen sulfide, as you know, if suppose it leaks, what will happen? That is the thing we have. So PHA is like this large inventory. Hazard is large inventory of high toxic hazard material. What is the cause? Failure of primary containment. If suppose the failure of primary containment happen, then potential for fatalities from large release, that hazard category is 4. And loss of reaction control in H2S process, the potential for fatalities from large release, that is hazard category 3. The next important technique is, sometimes I am skipping because actually this slide is 200 more slides are there. This is for 3-hour presentation because your time is only for 1.5 hours. So some slides I will skip. Only important things I will explain. So HASOP is actually very important technique. Anybody has any chemical engineers might be knowing about HASOP. This HASOP is, whether the HASOP is applicable to construction industry, is it? Can we apply HASOP to construction? Anybody? Anybody? Joyce, Helen, Satya. Joyce, Helen, Satya. Joyce, Helen, Satya is not responding. Mahadevan is there. Mini can respond. Mini is there. Mini OH. Okay, nobody is responding. So hazard and operability study can be only applicable to process industries because this HASOP is using a guide word and also it is applicable to certain parameters. Parameters are like pressure, temperature, flow, level, viscosity, all the things. So this is actually developed to identify and evaluate safety hazards in process plants, chemical industries, process industries, refineries, not suitable for construction industry. The purpose of HASOP is to carefully review a process or operation in a systematic fashion to determine whether the deviations from the design or operational intent can lead to undesirable consequences. So this is the definition of HASOP. I am skipping that. So HASOP team, there will be team. Suppose you want to do a HASOP team. Last 2 weeks before, I had done a HASOP work in one chemical industry, Travancore Titanium Products Limited. There, actually, we have done a HASOP study for a particular plant, particular process facility. So we have gone as a team. Myself, electrical engineer, a chemical engineer, 2 chemical engineers, and an electrical engineer was there. So what we do is we find out the deviation, the causes for the deviation. Deviation is nothing but what? See, all process or reactor is designed for certain pressure, certain temperature, certain level, certain stoichiometric ratio. It's supposed a deviation from that. Suppose more pressure, more level, less level, more temperature, more flow, all the things, the deviation from that we are finding out. And the causes for the deviation we list out, and the consequence for these problems we list out, and we recommend the various recommendations to address this problem. This is what happened. This is applicable to existing plant also, and also it is applicable to new plant. So this is our piping and instrumentation diagram. Before to understand the PNAD diagram, you have to understand the symbols of various. So now we can see a heat exchanger here. This is converted to PNAD. It will be looked like this. Just look, see carefully. And now I am going to convert this into PNAD diagram. It will be like. What is TRC? Anybody? TRC. Any chemical engineers? TRC is nothing but temperature, recorder and controller. TT, temperature transmitter. TI, temperature indicator. FCV, flow control valve. Plug in C. See the first letter. How do you understand the PNID diagram? Simple logic of understanding the PNID diagram. The first letter of the PNID will indicate the measured variable, pressure, temperature, flow, something like that. The next two letters will represent the function, recording, indicating, controlling. Like that function it will represent. So like this you can see temperature, recording, controller, temperature, transmitter, temperature, indicator. First letter is the function, temperature. Okay. And this is the instrumentation location. So if there is no line means the instrument is mounted in the field of nearby process. So it is nearby. If it is a sound line like this, the instrument is mounted in the control. In no line, the instrument is mounted far away. And these are the various valve symbols. Gate valve, control valve, globe valve, solenoid valve, plug valve, motor operated valve, all these valves. So these are the various places you can have. These are the various valves. The leakages can happen all these areas, seals, pump seals, and these are the various valves, ball valve, gate valve, globe valve, butterfly valve, all these valves. And this is a PNID example, TRC, TT, TI, TCV. Can anybody say what is FIC? FIC, flow indicating controller. TIC, temperature indicating controller. YIC, PLC indicating controller. TY, temperature computer output. FT, flow transmitter. TT, temperature transmitter. So where is HAZOP used? HAZOP can be used in chemical, petrochemical industries, oil and gas, power generation, mining, pharmaceutical material. Wherever process is there, chemical process is there, all the places we can use HAZOP. These are the gate words for HAZOP. No, more, less, as well as part of, towards, other than. These are the various gate words used in the HAZOP. No means what? No design intention is achieved. No flow. More, quantitative increase, higher temperature. Less, quantitative decrease, lower temperature. As well as additional activity. Other valves close at the same time of the dedicated valve. Part of means only some of the design intention is achieved. Only part of system is shut down. Reverse means logical opposite of the design intention, of course. That is the backflow when the system is shut down, other than the complete substitution of the activity. Liquids, gas pipeline, liquids in the gas piping. This is all complete. Or instead of ammonia, chlorine will come. The complete substitution. And the parameters are the various parameters like flow, composition, pH, pressure, sequence, temperature, signal, mixing, communication, reaction, time, stirring, phase, operate, transfer, all these things are the various parameters. The parameters is an aspect of the process that describes it physically, chemically in terms of what is happening. Okay, the specific parameters are those what describes aspect of the process. This is the HAZOP worksheet. So we can see the gate word here. This gate word is nothing but no, more, less, as well as these are the gate word. Parameter is flow, temperature, pressure, and all. So the gate word plus this parameter E will give you the deviation. So flow plus no flow. More plus temperature, more temperature. Less plus pressure, less pressure. Like that, the deviation. Now, cause consequence. This is how the flow chart that I am skipping. This is an example of HAZOP. You can just understand. This example is this example shows here we can have a material A, this is material B, actually material A and material B, and it will produce material C. Okay, the condition is that the material B's concentration should never exceed than of material A. If it happens, there is a chance of explosion. We can take parameters like flow or temperature, pressure, anything you can take. Now they have taken parameter called flow, and they have taken gate code no more or less. They have taken a node like this. This is the node they have taken. The first A node. This is the node they have taken. In this node, suppose no flow pay. What is the cause? Supply tank empty, pumps fail, pumps are mechanical or electrical failure, pump switched off, pipeline fractured. All this may be the reason for that. And if what will happen if suppose there is no flow to the tank, then automatically B will exceed. A is not coming means what? B is coming. So B will exceed its concentration. What will happen if B is exceeds? Explosion. Likewise, more or less, all these parameters can be utilized, and we can just list out which incident has the highest risk, and we can do risk metrics on our soap. Then if we do add a risk matrix to the soap, it will become a quantitative. Otherwise, it's a quality. So it will be a qualitative technique. And so, for example, also there, so I'm skipping because of no time. Next topic is fault tree analysis. Anybody has any idea about fault tree analysis? What is fault tree analysis? Fault tree analysis is mainly used for finding the cause. Suppose fault tree analysis can be used if suppose you got an accident. There is a fire, electrical fire, leakage. The fan is not rotating. The motor is not working. The TV is not working. Any equipment malfunction, we can do fault tree analysis. If any incident happen, accident happen, we can do fault tree analysis. Or it is also called cause-effect analysis or cause and effect diagram. So we are finding the exact cause. So various in the finally is a complex system. There are various causes for an incident to happen. For the combinations of various causes, which combination of causes leads to the top event of poor cause. That we find out by using the combination where which it leads to the what you can say the highest probability of which combinations can create a cause. So this is nothing but the fault tree inductive method that is used for this. Inductive models forward induce the consequences of the events. Deductive models backward reduce the cause of the event. So actually fault tree analysis is actually a deductive method that we are just finding the reason for that. But inductive method, that is event tree analysis, is actually finding out the various outcomes, the frequency of the outcomes of the event. We'll see what is fault tree analysis in detail. So while to do fault tree analysis, we need some certain equipment, certain logic diagrams we require. Logic diagram is nothing but logic symbols called AND gate, OR gate, intermediate gate, or maybe top event. All the symbols are to be used to develop a fault tree analysis. Yeah, this is the terms, fault tree analysis terms used, event, top event, intermediate event, basic event, undeveloped event, logic gate, Boolean algebra, blah, blah. So fault tree explicitly shows all different relationships that are necessary to result in the top event. In constructing the fault tree, a thorough understanding is obtained of the logic and basic causes leading to the top event. The fault tree is a tangible record of the systematic analysis of the logic and basic causes leading to the top event. So, fault tree analysis, why we do fault tree analysis? To exhaustively identify the cause of failure, to identify weaknesses in a system, to assess a proposed design for its reliability, identify the effects of human errors, prioritize the contributors, all that. Okay. So this is how the fault tree looks like. This is the top event. Can anybody know what is these gates? This is AND gates and this is OR gate. When to use AND gate, when to use OR gate? That is another question. When we have to use AND gate, when we have to use OR gates? Anybody? So the AND gate is used in a situation where all the inputs are required to create the output. Then at that case, we use an OR gate where we use any one of the input is enough to produce the output. That case we use OR gate. You know the two types of OR gate and AND gate. There are various symbols of gates. Okay, that's keeping and directly coming into the example. So here, this is a simple fault tree analysis. You can see the motor fails to operate. So it is used OR gate. That means any one of these is enough to produce this motor fails to operate. The first one is defect in the motor. Second one is no current in the motor. What is the reason no current in the motor? Why no current is in the motor? Switch may be open, wire failure, fuse fails, or supply failure. Why the fuse failure? Fuse failure is because of failure of overload, failure due to overload, fuse failure under normal conditions. Why overload happens? Again, it goes like that. It will go up to the last to find out what is the reason, detail the reason why the motor fails. This is nothing but fault. Why? Because how it becomes quantitative? If you assign the probability here, this probability, this probability, this probability, everything probability, you get a total probability of the event. So we can identify the total probability of failure of motor failure to operate is 2.13 into 10 power minus 4. Like that, we can calculate the frequency of occurrence of that particular incident. That is about the fault. The minimal concept I am skipping, actually, that is not required for you. Now come to event tree. As I mentioned, event tree is nothing but it is a cause effect analysis. Suppose leakage happened. Fault tree actually used to find out what is the cause of that leakage. You understand? Fault tree is used to find out what is the cause. Event tree is used to find out what is the outcome. So leak happened, LPG leak. Fault tree is used to find out what is the cause for LPG leak. Event tree is used to find out what is the effects, whether the LPG leak result in a jet fire, whether LPG leaks result in a pool fire or levy or VC. So what are the different outcomes we'll find out by using this event tree. So here the sample initiating event, failure of pump in a chemical industry supply speed to the process plant, failure of steering or agitator, failure of water cooling, stoppage of water, anything you can take it as a top events. So here you can see identifying a starting event of interest, then identify the safeguard designated to respond to the starting event, then constructing the event tree. This is how it looks like. Here, these you can see, these are all the safety functions. It's all our safety functions. And we find out the various. Now, I'll just show you an example here. This one. This is actually the various functions: automatic fire detection, manual fire detection, fire alarm, fire extinguisher. These are the safety functions. If gray color is means fire extinguish. Yellow color means controlled fire. This is uncontrolled fire. See, initiating event is fire ignition. There is a fire happened. So what will happen? Automatic detection activated. Then what will happen? And automatic detection activated means fire alarm activated. Fire alarm activated means it extinguishes the fire. And see, this is gray. Gray means fire is extinguished. If suppose automatic alarm failed, If automatic alarm failed means what? There is uncontrolled fire. If automatic fire alarm success, but fire alarm failed. Fire alarm failed means it is also red. Or fire extinguisher failed also. Like this, the different outcomes we can create. If suppose automatic alarm fail, manual alarm fail, fire alarm fail, fire extinguisher fail. So these are various different outcomes by using this event. So this is the inventory method. So you can add probability here. The probability you can see here. This is the probability. This is 0.12. If suppose 0.12, you know how this 0.88 you got? This 0.88 you got 1 into 0.2. 1 into 0.2 is 0.2. And 1 minus 0.2 is 0.88. Okay. Then this 0.88 is multiplied with 0.6. That is 0.261. Then this 0.88 minus 0.261 is 0.619. That note is not much required for it. This is how we can calculate the various probability. Next technique is an example. Here also same fault inventory examples are there. Fire and explosion toxicity index. This is actually a quantitative technique, fire explosion and toxicity index. Here we are finding out how the fire and explosion chance. Here basically we are using a formula. I just show you the formula directly. Yes. This is the formula. Fire explosion index is equal to MF. MF is nothing but material factor into 1 plus GPH total. GPH means general process hazard into 1 plus SPH, that is special process hazard. And whether this is comes in various ranges, we have to calculate whether it is high, low, medium, and we'll get the number also. Exact number of the risk number we'll get. And that is fire. Petty, we'll say it is fire explosion and toxicity. Fire index only this F. Toxicity index by using this formula, TH plus TS by 100. And this is the range for, if F&I index is 1 to 60, it is the degree of hazard is like, then 61 to 96, moderate, 97 to 120. Okay, now we come to this I'm skipping. Failure mode effect and analysis. This is the last one. Okay, 10 minutes, 10 more minutes is there. Failure mode effect and criticality analysis. This is actually a very important technique. This is mainly used for mechanical and electrical systems. Maybe electrical, aerospace industries or space missions and all we are using. Actually, here we are finding out the various this thing. I just show you. Failure. Failure analysis. All failure modes should be considered. Example: premature operation, failure to operate when required, intermittent operation, loss of output or failure during operation, degraded output. These are the various failure modes. So having identified the failure modes, the analysis, then look at the likely causes, then effects on both component and on the system. So whether it's safeguards against such failure method, predicting them are examined. Failure is nothing but the termination of an item's ability to perform a required function. Failure mode is the effect by which a failure is observed on the failed item. So these are the failure mode effect analysis, classification of failures, sudden versus gradual failures, hidden versus evident failures according to the effects, critical, degraded or incipient failures according to severity, catastrophic, critical or marginal or negligible, primary failure, secondary failure, and command fault. So this is the classification of failure mode. Fail to open on command. Suppose when you given a command of motor operated valve, we are giving a command close valve, we have to open it. But sometimes it will not open. That's actually a failure mode analysis. So fail to open, it is a failure mode. Fail to close, it is a failure mode. Leakage to the environment is a failure mode. So these are the various failure modes. Pump normally operating, fails on, transfer off, seal, leak, heat exchanger, leak or rupture, tube side plug, shell side plug, fouling, all these things are failure mode effect. So here this is the same example taken DAP process. This is the DAP process already I mentioned. So here if suppose phosphoric acid excess of specification product, NH3 excess, residual NH3 release. Both these things are excess, then out of specification product will be produced. So here a failure mode effect analysis is done. You suppose the valve B on the phosphoric acid solution line. This is identification. Description is motor operated valve fails to open. Fails to open means what happened? If valve B fails to open, excess flow of phosphoric acid to the reactor. Okay, that is the effect. And what are the safeguards attached? This is a simple way of FMEA. Now, like this, we can continue. Then next is failure mode effect and criticality analysis. What is FMECA? FMECA is a technique which is nothing but FMECA is extension of FMEA by including a criticality analysis which is used to chart the probability of failure modes against the severity of their consequence. The result highlights failure modes with relatively high probability and severity of consequences, allowing remedial effort to be directed where it will produce the greatest value. The risk priority number, which is the multiplication of O, S, and D, is used for prioritizing the failure modes in FMECA. And to use the risk priority number method to assess risk, the analysis team must rate the severity of each effect failure, and we have to rate the likelihood, and the RPN we calculate by multiplying the severity, occurrence, and degree of non-detection. I can simply explain. Suppose you take 1 to 10, severity 1 to 10. Severity 1 means very less, minor damages, minor injury. Severity 10 means 10 people died, 100 people died. So severity is 10 or more. Occurrence is nothing but frequency, as I mentioned, how frequently it is happening. So occurrence is, if you say it is 1 to 10 scale, calculate it in a 1 to 10 scale. If it is 1 means what? Very rarely happens. 100, once in 100 years, once in 50 years. If you put 10 means, every day it happens. Every week it happens like that. Degree of non-detection means, if suppose in a suppose inside a car there will be a component which is not able to detect at all. So if suppose if we are not able to detect that particular component, that degree of detection is high, 10. If we are easily detectable, then degree of detection is less. So that is the way we can calculate. So occurrence is like this. See, rank 1 to rank 10 like the severity also, rank 1 to rank 10. And likewise the probability also. And the RPN is calculated in this way. The RPN is less than 5, the rank is 1. RPN is very high, the rank is 10. So this is an example for calculating. In your components also, you can, research purpose also, you can use this technique. This is actually for LNG, Petronet storage tank. There are various components used over there. So the components failure mode is listed here. So here you can see the check valve leakage during the recirculation. So the occurrence, the expert elicit said it is 4, severity is 7, and non-detection is 3. So you can multiply these 3, you will get 84. So like this, we can prioritize. Here we can see the highest priority, number 1, that is 280, that is pump failure during normal operation. This has the highest probability, highest risk value. So we are prioritizing this particular failure mode can collapse the system. So if suppose 10,000 or 20,000 components are there, so we can prioritize which component is very critical, and we can give more redundancy or more seal value, more reliable products has to be, reliable components has to be used for critical operations. So all that things is very important for a continuous operation, and the system has to be operated with 100 very good reliability and very good without any failures. And this is a software is used for risk analysis. One software is called Aloha. Aloha is actually used for modeling dispersion, fire modeling, that is jet fire, pool fire, Blavey. All that modeling can be done by using a software called Aloha. So this is actually Aloha result. So if suppose we can give Aloha the details of the storage tank, the amount of liquid, what type of liquid, and if suppose it is leaked, how much area, you can see this is how much, 200 yards, that is a concentration, 10,000, 1000 ppm here, up to maybe 100 or 50 yards, the ppm, the concentration of that particular cyanide gas or carbon monoxide or any cyanide was 1000 ppm, and up to 600, 500 yards, it is 50 ppm. Like that we can have, and by using another software called Marplot, we can identify whether it is actually Marplot is Google Earth. Whether that particular area has a population density, very high population density, based on the wind direction, which direction the toxic gas is goes, and we can evacuate people to a safer direction by using this software. That is called Aloha. So this is Aloha and Marplot. We can estimate the threat zone, and we can identify the various. This is how the Aloha looks like. So that's it. So we have discussed various hazard identification and risk assessment techniques in a brief. That is like checklist, preliminary hazard analysis, what if analysis, ASOP, all three, inventory, and finally FMEA and FMECA, and the software called Aloha and Mark. So thank you so much for, but the participation's response was not up to the mark. Anyhow, I hope this is actually a FDP, you know. Thank you.
Dear participants, is there any queries?
Yeah, is there any questions, please? If you want to see Aloha, how to download Aloha and all, I can show you. If somebody is interested to do Aloha in your research or anything like that, student also can take the project of that. My contact
Sir,
number you can note in. Yeah, please.
Sir, please show that the Aloha.
Aloha. Yeah, Aloha I will show you. This is a software Aloha. Can you see? This is Aloha.
Okay, sir.
Okay. I'll just give you a small example. Suppose the site data, location you have to type. Actually, we can add location also. This all the drop down locations are American locations. But we can add location like this. Location you have to type. Suppose Ambalamugal. Ambalamugal you can type. Ambalamugal. Or maybe some. You tell me some location. Ambalamugal is already there.
Palakkad.
Palakkad, okay, right. Palakkad, some LPG that I use is diesel storage tank. Not in US. Elevation you put something, and latitude you put some. Latitude you have to check in Google. What is the latitude of Palakkad? I will just put 7 point something like that, and the longitude put 7623,
Yes, sir.
and then okay. Then country name India you put the. Then this one you have to put the. Then okay. India standard time okay 5.3. Okay. See Palakkad has been added. Now you can select Palakkad here. Right. Select you put, then it will come. Now I will select Ambalamugal. So Ambalamugal actually refinery is there now. So Ambalamugal India I have select. So this select. See Ambalamugal has come. Right. Then what you want to do is building type, just put the same single store. Then you go to date and time, okay. Then main important thing is chemical. Come to the chemical. Suppose I am taking a chemical like methane. You can take various chemicals, drop down list is there. Suppose you take a chemical called methane. I just put you methane. Methane you can put. Methane is nothing but LNG, no? LNG, methane. So methane. I select methane. Select methane. Okay. Yeah.
ഇവിടെ ക്വസ്റ്റ്യൻ ആൻസേഴ്സ് ആണ് കേട്ടോ. ഞാൻ ഇപ്പൊ എന്റെ പറഞ്ഞു കഴിയും. അപ്പൊ മിസ് ഇൻട്രോഡ്യൂസ് ചെയ്യണം. ഗ്രീഷ്മ മിസ് പറഞ്ഞില്ലേ മിസ്? ഗ്രീഷ്മ മിസ് കേറിയുണ്ട് ഇതില്.
Okay. Then atmosphere, then user input you have to put the wind speed, you have to put some 8 meter per second. Wind is from, for example, it is east, south, east, and all that things you can give. And you can give the air temperature is 30 degrees Celsius. And next is the source. Source, you have different source. Source is direct puddle tank. I am taking tank. Tank itself, we have 3 things are there: cylindrical, horizontal, and sphere. Cylindrical, I am taking the diameter. I am putting something around 50 meter, and the length I am putting something around 40. And you can see, and the tank contains liquid at not ambient temperature. It is kept at minus. Actually, see in LNG, you know, minus 162.5 degrees Celsius. It is kept. And the tank level also you can give. How much tank is filled? The tank is filled up to maybe 86%. You can give 86%. Leaking, burn as a food fire. Okay, this you can give. Leaking tank. Leaking tank chemical is burning and forms an evaporating puddle. Leaking tank chemical is burning in the food fire. All these options you can have. First option I am choose, and the opening diameter I am putting some 50 centimeter hole size I am putting, and a big hole. Suppose the hole, where is the hole? You can identify where is the hole. You can type, and this all defect. And then now this is display threats on toxic area. You can have a toxic area like this. So this much area is a toxic area. And also you can have mark plot is also there. This is a mark plot. If you open the mark plot, you can just how to download also I will show. This is very simple. You can download easily, and you can have a threads on sharing. Mark plot is here. So go to the map. You can see. This is, you can see in Kochi. Kochi, this is the LNG Petronet, you know, might be knowing LNG Petronet. So this is the area, and you just go to here and search source point. Here you see. Based on the wind direction, it goes to the sea. I have given east to southeast, so it goes west. So it goes like this. If you change the wind direction, it will be going some other place. So this is one. And if you select for this one, no threat zone for flammable area, you will give another flammable area. Sharing, mark plot. This is the flammable area. See, it goes like this, flammable area. And again, you can see blast area. That is the threat zone, blast area like this. Okay, and okay, this is the blast area. Sharing, mark plot. Go to the blast area. Like this, we can have any places. See, this is actually Wellington Island, Kochi. This is Kochi only. This is Kerala only. I just put. You can see this is Kerala. It's India only. Okay. This is Marport is just associated with Google Earth only. So you can have any location here in India. I have selected Kochi. LNG Petronet. Everybody knows about that. LNG. LNG, no, gas pipeline. Gale. So this is the location I have put. You can see this is a storage tank here. So if you want to see the BPCL refinery, you know, refinery is all refinery storage tanks you can see. These are the various storage tanks in the refineries. Kochi refinery. This is Kochi refinery. You can have a dispersion modeling, all various tanks in Kochi refinery, and various dispersion models and all can use. Yes, any other queries, please? And I will share my contact number in this chat box. If anybody, I am fastly explained about Aloha. If you have anybody doubt, you can call me in this number 90483
Please
77.
view that Aloha definition.
Aerial location of hazardous atmosphere.
Please view that slide. Show
Slide.
that slide. Okay.
Slide. Okay. Can you see? Aloha.
Yes.
Aerial
Yes.
location of hazardous atmosphere.
Yes. Sir.
This is what. Okay. Anybody? Anything else? Yes.
Have the
Please.
previous slide. Previous slide.
Previous slide.
Next. Yes.
Mark.
Okay,
It is
okay,
very
sir. Okay,
easy
sir.
to.
Thanks.
It is very easy to download, sir. Just go to Google. You can just Google and download Aloha like this. Download Aloha. It's very simple. Download Aloha. Then you go to a website called this website. Okay, U.S. Environmental Protection Agency. www.epa.gov. www.epa.gov. Okay. Then come down. Download Aloha for Windows. Like this. It will be downloaded like this. Now it is downloading. Just 2 minutes it will be downloaded. Within 2 minutes it will be downloaded. Then set up. That's it. Now it is getting downloaded. And it is,
Okay, sir. Okay, sir. Clear,
yeah,
clear.
very simple. Nothing.
Okay, sir. I will contact you.
Yeah,
for
you can
further.
contact me anytime.
Okay, sir. Thank you.
Anybody else? Have any other doubts? Yes, madam. Please, there is no doubts, please.
Okay, thank you, sir,
Yeah.
for the session. The session was very interesting and interactive. Once again, thank you, sir.
Thank you.
Next-
Thank you.
Okay, next session will start soon. Please
Okay.
stay back.
Thank you. I am leaving.